Good morning to all. Last class we have learned about measurement, unit, fundamental units and derived units. We have learned last class. So today, did you learn, students, that portion? Measurement and derived units, so many formulas we have learned, and unit we have learned. Yes, very good. The next topic we can see what are the rules and conversions to write the symbol and the unit. There are 10 rules are there. Very, very important question. Just listen what are the rules to write the symbols and units. So first rule, already we have learned in the derived units, formulas we have learned, fundamental units, formula, unit and all you have learned. So first, the unit of electric current. Already all of you know the unit of electric current. What is the unit of electric current? Ampere. Ampere is the unit of electric current. The symbol of the ampere is capital A. Then what is the unit of force? The unit of force is Newton. The symbol of Newton is capital N. This already you have learned fundamental units, you have learned this electric current, and the derived units formula you have learned force formula. What is the formula for force? Mass into acceleration. The unit of force is Newton. Like that you have learned. Now listen here. Here the scientist name, this Ampere, Newton, the scientist name. So the first rule is the unit named after the scientist should not be write as initial capital letter. So you have to write small letters. Here A and here N, small letters you have to start. Okay, the first rule, the unit named after the scientist should not write with the initial capital letter. So this is the first rule. Now listen, symbol. Symbol we have to write capital A and here capital N. So the second point is the symbol of the unit. First point, symbol alone will say, unit alone will say. Then second point, the symbol of the unit named after the scientist should be write as the initial capital letter. First point should not, here should. So the symbol of the units named after the scientist should be write as a initial capital letter. The third point is the small letters are used for the symbols. Third point, small letters. Suppose kilogram. Kilogram. What is the symbol of kilogram? Kg. Now meter. What is the symbol of meter? Small m. So the small letters are used for the symbols. So kilogram, kg, meter, m. Then here suppose 5 kilogram. We have write 5 kilogram. Here should not use any full stop or punctuation mark. Punctuation mark, comma, quotation, question mark, exclamatory mark, these are the punctuation. So should not write full stop at the end of the symbol, full stop or any punctuation mark. The next one, the temperature. Last class we have learned about the temperature measured in 3 scales. What are the 3 scales? Celsius scale and Fahrenheit, Kelvin. So 3 scales are there. Suppose here 100 degrees Celsius. So degree is must for Celsius scale. Then here 100 degree Fahrenheit. There also degree must. But Kelvin, when we are expressed in Kelvin, the degree sign is omitted. So degree, don't write here degree. If you write degree, that's wrong. So Kelvin, when we measure in Kelvin, the degree sign is omitted. So 3 scales are there, degree Celsius, Fahrenheit and Kelvin scale. So the Kelvin scale, degree sign is omitted. Next one, the solidus. Solidus means slash or per or divided by. So suppose the unit of velocity. What is the unit of velocity? Last class we have learned. What is the unit of velocity? Meter per second, or we can write meter second power minus 1. So here only one unit, per divided by, after only one unit is value. Suppose here joule per kilogram per mole. This unvalued. Why means here 2 solid symbols we used. So this we can write joule, kilogram power minus 1, mole power minus 1. Like that we can write. So here the solidus is recommended. We are indicating the division of one unit to another unit. Okay. The next one, the accepted symbols only used. So here ampere. So symbol, what is the symbol of ampere? A. So this only accepted symbol. Don't use amp. A-M-P. Don't use for ampere, amp. So accepted symbol, what is that? Capital A. Now second SEC. So this not accepted, only the accepted symbol is yes. Like that accepted symbol only we have to use. Next, numerical numbers. Suppose the density of mercury. What is the density of mercury? 13,600 kilogram meter power minus 3. This is the unit, the density unit. So the density of mercury, what is the value? 13,600 is the density of mercury. The unit is kilogram meter power minus 3. This numerical value. So this we have to write in scientific form. So that 1.36 into 10 power 4 kilogram meter power minus 3. So the scientific formula we have to write. So these are the 10 rules are there. Then 5 kilogram. This singular plural, all of you know. 5 kilogram. Kilogram means singular. Suppose 5 kilograms, that is plural. So should not write this plural form. So we should write 5 kilogram alone. We have to write. Don't put here yes. Plural form don't write. Only 5 kilogram. And this 5 is the numerical number. Kilogram, that is unit. So we should separate some space. Numerical number and unit. We have to separate space. So these are the 10 rules and conversions to write the unit and symbols. So you have very important question. You have to learn this 10 rule. After I will mark and give the question. So first one, the unit named after the scientist should not write with the initial capital letter. Second one, the symbol of the units named after the scientist should write with the initial capital letter. Then small letters are used for the symbol of units. Next, no full stop or punctuation mark should not be used. Then use of the solidus symbol. Solidus symbol, only one unit only we have to use. Then the number and the unit should be separated a space. Then accepted symbols only we have to use. That is example, ampere should not use amp, only capital A alone want to use. Second, should not use SEC, only the symbol S alone should be used. The numerical values of physical quantities, so that is the example density of mercury. So the value is 13,600. So we have to write that 1.36 into 10 power 4. The unit of density is kilogram meter power minus 3. So just you have to learn this 10 rules. So next one, in our daily life we have to use the scale. This all of you know, to measure the length. Suppose you want to measure 5.1 centimeter. By using the scale we can measure. This all of you know. 5.1 centimeter want to measure means by using this meter scale we can measure and draw a line. Suppose 2.5. 2.3, this everything we can measure. Suppose here 2.51. Can you measure by using this meter scale? So we cannot measure by using this meter scale. So Y means the least count of this meter scale is 1 millimeter. What is the least count? 1 millimeter. Least count of this meter scale is 1 millimeter. So we cannot measure the value 2.51 centimeter. We cannot measure. For that we are using instrument is the Vernier Caliper. What is this? Vernier Caliper. So the least count of this Vernier Caliper is 0.1 millimeter. So the least count is 0.1 millimeter. 0.1 millimeter. The least count of is Vernier Caliper. What is this? What is this instrument called? Vernier Caliper. So the least count of this Vernier Caliper is 0.1 millimeter. We can write this in centimeter, that is 0.01 centimeter. Now listen, we can learn about the description of a Vernier Caliper. We can learn now the description of a Vernier Caliper. Or listen here. So it consists of a long thin bar, steel bar. Okay, a long thin steel bar is graduated in centimeter and millimeter. Here centimeter and millimeter. It is graduated in centimeter and millimeter. This scale is called main scale. Okay, so the Vernier Caliper consists of a thin long steel bar graduated in centimeter and millimeter is called the main scale. So we have to write this. Here main scale. So this diagram of the main scale, and here in this instrument, here this is the main scale. Now Vernier scale, two scales are used, main scale and Vernier scale. This Vernier scale just slides above the main scale. The Vernier scale just slides above the main scale. Then this Vernier scale consists of 10 divisions. Here 10 lines are there in this Vernier scale. So the Vernier scale consists of how many divisions? 10 divisions are there. Vernier scale consists of 10 divisions are there. Now here two jaws are there. This upper jaw and lower jaw. What is this? Upper jaw and lower jaw. See, by using this retainer, what is this? This retainer. By using this retainer, we can move here and there. See, we can move here and there by using this retainer. So, two jaws are, one upper jaw and lower jaws are fixed jaw. And upper jaw and lower jaws are movable jaw. By using this retainer, we can move here and there. Okay. Then, at the end, at the right side of this Vernier scale, a thin bar is attached. This bar is called depth probe. What is this? Depth probe. This depth probe. A thin bar. What is this? Depth probe. So here two jaws are there, upper jaws and lower jaws. Vernier scale, main scale and depth probe. These are the description of a Vernier Caliper. Now what is the use? What is the use of this upper jaw? To measure the internal dimension of an object. Okay, object we want to grip here. After I will show you. So this upper jaw is used to measure the internal dimension of an object. Lower jaws are used to measure the external dimension of an object. So upper jaws are used to measure the internal dimension of an object. Lower jaws are used to measure the external dimension of an object. What is the use of this depth probe? To find the depth of an object. Which object we are gripping here? That object's depth we can find by using this depth probe. So now listen, depth probe spelling, depth probe, P-R-O-B-E, depth probe, retainer, then upper jaw and lower jaw. Then Vernier scale, here given Vernier scale, main scale, then upper jaw, lower jaw. So the object grip in between the two lower jaws, the objects are grip. So these are the description of a Vernier Caliper. Once again, say it consists of a thin long steel bar is graduated in centimeter and millimeter is called main scale. The Vernier scale is slides above the main scale. The Vernier scale consists of 10 divisions are there. It consists of two upper jaws and two lower jaws. So one upper jaws and lower jaws are fixed, another one is movable. So the upper jaws is used to measure the internal dimension of an object. Lower jaw are used to measure the external dimension of an object. This depth probe is used to measure the depth of an hollow object. Now what purpose we are using this Vernier Caliper? To find the thickness of an object. Suppose we can grip the ball here. See, in between the two lower jaws. A rubber ball, we can grip the ball in between the two lower jaws. We can find the thickness of this rubber ball or diameter of a rubber ball. We can find by using this vernier caliper the thickness of a rubber ball or the diameter of a rubber ball. Then how we can use this vernier caliper, we can see. First, in this vernier caliper, we have to find out the least count. How will we find the least count? So, least count. The short form LC. So, the least count equal to, formula is there, the value of one main scale divisions, MSD, main scale division. MSD means main scale division divided by total number of vernier scale division. So the least count formula, the value of one main scale division divided by one smallest main scale division, that is 1 millimeter. Okay, the value of one smallest main scale division divided by total number of vernier scale division. Now what is the value of one smallest main scale division? That is 1 millimeter. 1 millimeter or 1 centimeter divided by total number of division. How many divisions are there in a vernier scale? 10 divisions are there. So 10. So 1 divided by 10, what is the value? 0.1 millimeter. This we can write in centimeter, 0.01 centimeter. So the least count of this vernier caliper is 0.1 millimeter and 0.01 centimeter. Suppose problem, the MS or value given in millimeter means you can use this least count value. Suppose centimeter given means you have to use this least count value. So like this we can find the least count of a vernier caliper. So the formula to find the least count of a vernier caliper is the value of one smallest main scale division divided by total number of vernier scale division. One smallest main scale division is 1 millimeter divided by how many divisions are there in a vernier scale? How many divisions are there? 10 divisions. So 1 divided by 10 you will get 0.1 millimeter. Suppose given in centimeter means you have to use this least count 0.01 centimeter. So in this vernier caliper, first you have to calculate least count. So by using this formula we can calculate. Then how we can write by using this formula itself we can write the definition. See how we can calculate the least count. Least count of the vernier caliper is the value of one smallest main scale division to the total number of vernier scale division. Then you have to write this value and the 0.1 millimeter. This much you have to write. Next, we can learn about zero error. Zero error of a vernier caliper. Zero error of a vernier caliper. When you have to find the zero error, the two jaws are contact each other. See, the two jaws are contact each other. When we have to measure error, first two jaws are contact to each other. So here 10 divisions are there in a vernier scale, already I told. Then the main scale also divisions are there. The zero of the vernier scale is just coincides with the zero of the main scale. There is no error. So 2 also coincides means there is this vernier caliper has no error. So no error means the zero of the vernier scale is just coincides with the zero of the main scale is called no error. Suppose this vernier caliper has error means there are two types of error is there. One is the positive zero error. Positive zero error. Next one, negative zero error. Now we have learned about the positive zero error first. After that we can learn negative zero error. When you should learn positive zero error means negative, very easy. So just see this diagram. Suppose here 0, here 1, then 2, like that going on. This which scale? Main scale. This main scale. So Vernier scale has 10 divisions are there. So here 0, here 5, here 10. So total here Vernier scale. 2 scales are there, main scale and Vernier scale. Now listen, positive zero error means the zero of the Vernier scale. The zero of the Vernier scale just shifted to the right of the main scale 0. This main scale 0. The 0 of the Vernier scale just shifted to the right of the main scale 0 is called positive zero error. So positive zero error, the 0 of the Vernier scale just shifted to the right of the main scale 0 is called the positive zero error. So negative zero error means just here right, there left. Now the formula for positive zero error. Positive zero error. So P means positive, Z means 0, E means error. So positive zero error equal to N into LC. So the formula for positive error, what's the formula? N into LC. What is N? L means what? N means which line, which division quantized. See here, see the 0. Here this main scale reading, this Vernier. What is the meaning of quantized? Listen, here 1, here also not quantized. But see this fifth division, see 2 also in same line. So this only quantized. So we can take this fifth division. So instead of N, we have to write as 5. So 5 into the least count in millimeter, we can write 0.1. So multiply and write 0.5 millimeter. Like that we have find out positive zero error. Suppose the positive zero correction. Zero error positive means 0, correction negative. 0 error negative means 0, correction positive. So here positive. So the formula is minus N into LC. So minus 5 into 0.1. So you'll get minus 0.5 millimeter. Like that you can get positive zero error and positive zero correction. Suppose the least count is in centimeter. So what's the value? 5 into 0.01. So you'll get 0.05 millimeter. So here negative zero, positive zero correction, you can write as minus 0.05 millimeter. Like that you have to find out the positive zero error. Now listen, positive zero error, the 0 of the Vernier is shifted to the right of the main scale 0 is called positive zero error. So the 0 of the Vernier scale is just shifted to the right of the main scale 0 is called positive zero error. The formula for positive zero error is N into LC, and the positive zero correction formula minus N into LC. Next we can see the negative zero error. Negative zero error, here we will write right side. Now there negative zero error we have to write left side. Okay, the 0 of the Vernier scale is just shifted to the left of the main scale 0 is called negative zero error. So negative zero error just shifted to the left of the main scale 0 is called negative zero error. So the negative zero error formula is minus of 10 minus N into LC. So what's the formula? Minus of 10 minus N into LC. How will we get to this 10? Vernier scale has 10 divisions are there. So we can write here 10 minus N. Which line quantifies? That we have to write as N. Least count means millimeter means 0.1, centimeter means 0.01, least one you have to multiply. Suppose here 8th line quantifies. So 10 minus 8 into millimeter, so 0.1 least count. So next line minus of 10 minus 2, 2 into 0.1. So equal to minus 0.2 millimeter. Like that you have to find negative 0 error. Suppose here negative 0 correction. The formula is 10 minus n into LC. What's the formula? 10 minus n into LC. So 10, number of divisions 10. Suppose 8th division coincides. Here instead of n you can write 8 into 0.1. So next 2 into 0.1 you will get 0.2 millimeter. Suppose is in centimeter means 0.01 you have to multiply. So like that we have to find out the negative 0 error. What's the formula for negative 0 error? Minus of 10 minus n into LC. Minus of 10 minus n into LC. That's a negative 0 error. Negative 0 correction formula 10 minus, don't write minus, 10 minus n into LC. So like that we have to find out the 0 error. So first there is no 0 error means two jaws are in contact. There is no 0 error, two jaws are in contact. So 0 of the main scale and the 0 of the vernier just coincides each other. There is no error. There are two types of 0 error is there. What are the two types? Positive error and negative error. So positive error, the 0 of the vernier scale is just shifted to the right of the main scale 0 is called positive 0 error. The formula already we have learned, n into LC is the formula. Now negative 0 error, the 0 of the vernier scale is just shifted to the right of the main scale 0. So that is the negative 0 error. The formula for negative 0 error is minus of 10 minus n into LC. 0 correction means here minus, there plus it will come. So like that we have to find out the 0 error. So first when you get this vernier caliper, first you have to find the least count and the 0 error of a vernier caliper. Next one, how to find the thickness of a object. Suppose here, suppose we are gripping inside this rubber ball. This rubber ball gripping inside the, in between the two lower jaws, the object is there. Now first we have to find the main scale reading. We have to find. How we will find means the vernier scale consists of how many divisions? 10 divisions are the first division here. What value is there in the main scale reading? That really first main scale reading. You have to find out the main scale reading. So we will get here 6. The main scale reading is 6. So first we have to write main scale reading, that is MSR. MSR, M means main, S means scale, R means reading. Next one, vernier constants. VC means vernier constants. VC means vernier constants. Next line, VC into LC. Then next we have to write formula. The formula to find the thickness of an object or diameter of an object is MSR plus VC into LC plus or minus VZC. VZC means 0 correction. MSR main scale reading. MSR means main scale reading. Then VC means vernier constants, LC means least count, VZC 0 correction, 0 correction, this plus or minus. So the formula to find the thickness of an object or diameter of an object, MSR plus VC into LC plus or minus VZC is the formula. First we have to find here in centimeter we can write or millimeter we can write. So here 6. The MSR reading 6. Then vernier constants, suppose the which division coincides means 4th division here coincides. So we can write here 4. The next 4 into, what's the least count in millimeter? 0.1. So you'll get 0.4 millimeter can get. Then this reading we have to write in this formula. You can substitute this formula. So instead of MSR, what's the value? 6 plus BC into LC. Already we have find out 0.4. Then here there is no error. There is no, this Vernier caliper has no error. So the zero correction no need to find. So just we can write this. So 6 plus 0.4. Listen here, 6 is the whole number. 0.4 is the decimal number. So just add means you will get 6.4 millimeter. Like that you can find the thickness of an Vernier caliper, thickness of an object. We can find by using this formula. What is the formula? The observed reading formula. MSR plus VC into LC plus or minus VZC. What is the formula? MSR plus VC into LC plus or minus VZC. MSR main scale reading, Vernier constants, least count, VZC means zero correction. So like that you have to find out. Then the regarding this problem also there, by using this formula you have to do problems. Some examples problems are there inside the book. Just you have to do. Then the numerical problem, Rome letter 9 on problem is there. Just we can do now. See, they are given the main scale reading of a rubber ball, like this one rubber ball. Main scale reading of a rubber ball is given as 7 centimeter. So given, you can write like this. What is given in the question? MSR, main scale reading, equal to, what's the value? 7, given in centimeter. So 7 centimeter. You have to write 7 centimeter. The main scale reading of a rubber ball equal to how much is 7 centimeter. The next least count. So centimeter, what is the least count? 0.01 centimeter. The least count in centimeter. Main scale reading given in centimeter means least count also you have to find in centimeter. So least count equal to 0.01 centimeter. This they won't give in the question. We have to write this value. Then Vernier constants, this given, so VC equal to 6, 6th division constants. In this question, in that question given, Vernier constants, which division? 6th division given. Then what is given? This much given. So MSR, main scale reading equal to 7 centimeter. Least count, this we have to write 0.01 centimeter. Suppose this given in millimeter means you have to write the least count value 0.1 millimeter. Then VC value, Vernier constants given in the question, 6th division given. So VC equal to 6. You have to write. Then we have to find the radius of a rubber ball. We have to find that problem, radius of a rubber ball. First, we can find the diameter of a rubber ball. Diameter of a rubber ball. The formula, this formula, MSR plus VC into LC. Then here there is no error. In that question there is no error. So formula this much enough. MSR plus VC into LC. Now you have to find out MSR. What's the value of MSR? 7 plus VC. What's the value? 6 into least count in centimeter 0.01. So you will get 7 plus 0.06. So you can write this. 7 is the whole number. So this decimal number, some point here 0.06, here 0, 0. So you can add like this. So 0 plus 6, 0, 6, then 0, then 7. So you'll get to 7.06 centimeter. You have to write in centimeter. Why we have to write in centimeter? MSR rating given centimeter. Least count we have to multiply centimeter. So the answer also you'll get to 7.06 centimeter. In that question we have to find radius only we have to find. But we have to find out diameter. So the diameter formula all of you know. Diameter equal to radius divided by radius equal to diameter divided by 2. Radius only we have to find out. So radius equal to diameter divided by 2. So what's the value of diameter? 7.06 divided by 2. So just to divide means you will get the answer. We can divide this 7.062. Remainder 1, then 0.0. Put here point, then 5, then again 6 is there, 3. So you will get the value radius equal to, radius of a rubber ball equal to 3.53 centimeter. So this is the answer. First, what is given you have to write and apply the formula, then substitute the value, then write answer and unit. Unit very very important. So near the answer you have to write the unit. Suppose this given in millimeter means you have to write the least count 0.1 millimeter. So here multiply 0.1 millimeter, multiply and write the unit millimeter. So just to check the question, if you are given in millimeter means the last answer also in millimeter. Suppose given in centimeter, last answer also in centimeter. Okay, so these are about this vernier caliper. So we have to learn the description of a vernier caliper, least count of a, how to find the least count of a vernier caliper, how to find the zero error of a vernier caliper, and how to find the diameter or thickness of a rubber ball by using this vernier caliper we have learned. So all of you know the formula. What is the least count formula? Least count value only given here 0.1 millimeter, 0.01 centimeter. What's the formula for least count? The value of one smallest main scale division divided by total number of vernier scale division is the formula. Just substitute means you will get the answer. Then zero error are in two types. What are the two types of zero error? Positive zero error, negative zero error. Positive zero error formula n into LC. The negative zero error formula minus of 10 minus n into LC. So by using this vernier caliper we can find out the least count, zero error and the thickness of a vernier caliper. See, nowadays available digital vernier caliper also available. So digital vernier caliper is there means now digital word, so everyone willing to use this digital vernier caliper. So there we no need to find the least count and zero error, no need to find, just we will get the slider. The slider we will get the numerical value, we will get the slider. Okay, so just to mark the question. So page number 12, Rome letter 7, first question. Write the rules that are followed in writing the symbols of units in SI system. So page number 4, the rules and convention for writing SI units and the symbols. Total 10 points are there. Any 7 points you can learn. Any 7 mark, if they ask 7 marks, 7 points you have to write. 5 mark, if they ask means you have to write 5 points. The next question, fourth question, Rome letter 7, fourth question. How will you measure the least count of a vernier caliper? That page number 5, the least count heading is there. So just you write the formula and substitute the value. So least count of the instrument equal to value of one smallest main scale division divided by total number of vernier scale division. Then LC equal to 1 divided by 10 equal to 0.1 millimeter equal to 0.01 centimeter. The Rome letter 9, problem number 2. That problem only given in the blackboard. Just note it down. So next class, just you learn this question, Rome letter 7, first question and fourth question and problem also, just do it. Thank you.